to me is Aaron Isaac Antonio, Alexander Dane Mamba, Mark Daniel Mendoza, and Mike Andrew Castillo. And we will present our project titled Fake Bus Circuit. To begin, let me describe our concept. A bus is a type of transportation that can convey a large number of passengers to their desired location. And this is where the group circuit design was inspired. Fake bus circuit was the name of the circuit diagram. The electrical components of fake bus circuit are diverse. Ground, voltage supply, resistors, and ammeter are the electrical components. The fake bus circuit involves the relationship of voltage, electric current, and resistance despite the fact that it is complex circuit diagram with several branches and loops. The fake bus circuit will be further discussed as the project progresses to different sections. In addition, in every circuit, an Android circuit simulator, the fake bus circuit will be emulated.
Good day, I am Engineer Mamba and I will discuss about theoretical background. To understand electrical circuits, we need first to understand the concepts and theories involved. So in our first laboratory experiment, we utilized primarily the Ohm's law and Kirchhoff's law in some parts. Basically, the Ohm's law comprises of three values: voltage, current, and resistance. And it states that in an electrical circuit, the current is directly proportional to voltage and inversely proportional to resistance. And using this concept, we can calculate each of individual voltages, currents, and resistance. Also, Ohm's law states that there are different approaches when it comes to series and parallel circuits. In series circuits where there is only one path, the current is equal all throughout the circuit. While in parallel circuits where there are two or more paths, the voltages are equal. In a series parallel circuit, the concepts of series and parallel circuits are combined to calculate the values of each of individuals, resistance, voltages, and currents. And in Kirchhoff's law, there are two laws: Kirchhoff's voltage law and Kirchhoff's current law. In Kirchhoff's voltage law, it states that the algebraic sum of potential differences in any loop is equal to zero. While in Kirchhoff's current law, it states that the summation of entering current is equals to the leaving current in a circuit. So, summarizing it all, the Kirchhoff's law and Ohm's law are the basic concepts and theories to be understood first before solving any circuit.
This is our circuit diagram. It contains 8 meshes, 21 branches, 10 dependent loops, and 13 branches. And yon based dun sa pangalan ng aming circuit na fake bus. Mukha naman siyang bus. Then, syempre, may nire-represent yung bawat electrical components niya. Una, yung voltage supply. Ang nire-represent niya dito is yung ilaw ng bus. Then, yung dalawang meshes sa taas, yun yung bubong ng bus. Then, yung 3 meshes naman na nabuo ng mga resistor sa may gitna. Una yung bintana, then pangalawa, yung nasa gitna yung pinto, then yung nasa kanan is yung pinaka bintana ng driver. Then yung dalawang meshes sa baba, ang nire-represent niya is yung compartment ng bus. Then sa ground, ang nire-represent naman ng ground is yung tambucho ng bus. Tapos yung dalawang ammeter, Ang nire-represent niya yung gulong. Pinalitan namin ng ammeter yung dalawang lamp. Lamp kasi nakalagay dyan nung una. Ginawa naming ammeter kasi para ano na rin, para ma-measure niya na rin yung current. Then, ayun. Tapos yung voltage supply nga pala, meron siyang 10 voltage. Ayun lang.
So, good day everyone. I'm Aaron Isaac P. Antonio and I will be discussing the results and discussion. So, in this part of the project, the data gathered in the design circuit will be discussed and analyzed furthermore. So, we have here the um, tables of values. So, it has total resistance, total voltage, circuit current, individual resistances, voltages, and current. So, the unknowns here are the total resistance and the voltages. So, we've obtained those value by using Ohm's law. And I will not be discussing here how we've calculated these values because it will take too much time because we have here too many resistors and it will take too much time to solve this. And like what I've said, we've just obtained this by using Ohm's law. So the results and discussion were just after here because of the interpretation of data. We need to interpret this data. So we have here two types of data. First one, we have here the numerical data which is presented here and the descriptive data by means of observation. So first one, we need to interpret the numerical data. So observe the resistance 1 to 7. So it has a constant value of 16 ohms. And look at their voltages and current. So look at those. As we have noticed, as the voltages increases, the current is also increases, and the same with the current. So as the current increases, the voltages increases. So meaning to say, the voltage drop is directly proportional to the current. So that's one. Next one, we have here the R sub 19. So the R sub 19 has a resistance value of 500 ohms and it has a 3.96 volts and it has 7.93 milliamperes. So as we have observed, the voltage drop in R sub 19 is the highest among the voltage drops in other resistances. So, but why does the current is 7.93 milliamperes while the look at the R sub 1? So the voltage in R sub 1 is 0.858 volts, but the current is 14.3 milliamperes, which is greater than the current in the R sub 19. Why does it happen? So it happened because it has a higher resistance value. The resistance value affects the current. If you have a certain value of voltage, if you have a higher current, if it's so 500 higher resistance rather. So if you have a higher resistance, the value of current will decrease. That's why it has only 7.93 milliamperes. So what I can conclude here, so there is a direct proportion in voltages and current, and there is an inverse proportion in resistance and current. So this just tells that the Ohm's law is being applied in this circuit and it is proven by this numerical data. So that's it for the numerical data. So in numerical data, we've proven that the Ohm's law is being applied in our circuit. So the next one. So we have here our circuit, as you have seen. So the conventional flow is from right to left. So and the total and the voltage supply produces 42.9 milliamperes. And this 42.9 milliamperes is dissipated into three electrical paths. It is from here, here, and here. And as we have noticed that if we add the current that flows into three electrical path, it will be equal to the um, circuit current, which is the 42.9 milliamperes. So the next one is the current that flows into those three electrical path will enter in two electrical paths. So where it is? So it is here and here. So that's it. So as we have noticed, the values changes. So it is 19 and 24 milliamperes. So I think it is because the dissipation of electrical current in electrical path is mixed up. That's why it changes from 19 milliamperes and 24 milliamperes. So just ignore this because let's just say that it is only two electrical paths, because if we just add up the current of those, it will just be equal to 24 milliamperes. So it is very insignificant to notice those. So with that, so look at the value. We have here 19 milliamperes and 24 milliamperes. And if we try to add this up, it will be approximately equal to the um, values of current that enters into three electrical paths and to the values of current that enters into two electrical paths. So here in two electrical paths, we have here 43 milliamperes. So it is approximately close to 42.9 milliamperes. And as we have noticed, as the as the current goes to the left, it goes down into this area. It goes down. And when it reaches the ammeter, um, it reads that it is 42.9 milliamperes. So meaning to say, the the current that lives here is equal to 42.9 milliamperes. So what I can conclude here is that what does leave must go out. So I think Kirchhoff's law, specifically the Kirchhoff's current law, is being applied here. Imagine the values of current that enters into this area is equal to the current that lives here, which is equal to 42.9 milliamperes. So what I can conclude here is that the sum of electrical current that enters into a certain electrical paths or nodes is equal to the electrical current that leaves a certain electrical path or node. So meaning to say, Kirchhoff's laws is applied in our circuit and it is proven here. So that's it. Thank you.
For the conclusion, in designing a circuits, the electrical components that we will be using should be considered, such as how many resistors should be used, the voltage supply, and the load that should be putted. Also, the other thing that need to be considered is to know how these electrical components work so that someone can analyze how it will behave in the circuits. Moreover, the theories and concepts of electricity should be considered, such as Ohm's law, Kirchhoff's law, principles of different types of circuits, and many more, to have an to have an effective circuit. Also, as an addition, theories and concepts of electricity helps us to understand the complexity of electricity in a certain circuit to analyze its deepest it can be. Summing all of those, therefore, the circuit's design is more on a abstract art. You need to have a better understanding before you can create a better one.